Aloha mai kākou. I hope you guys are doing awesome wherever you are. And I hope you're thankful for all that God is blessing you with, whether it's family, friends, living in Hawaii or wherever you live, and going to Kamehameha or whatever school you go to. I just hope you have a thankful heart. This is section 12.1, which is graphing rational functions. Before I get into that, I just want to review or show you 6 different types of functions that we may have covered or may not have covered, but at least now I want to show you what it looks like. So if you see the graph, you know what type of function it is. So the first one is a linear function, y equals mx plus b. This is where x is to the first power. There's an invisible one there. And this is where you're going to get a straight line. So if it's y equals 3, it actually looks like this. If you remember, a horizontal line on y equals 3. And if it's x equals 4, you get a straight vertical line on x equals 4. Or if it's y equals 2x plus 1, that's the one where the y-intercept is 1. Your slope is 2, so you go up 2 over 1, down 2 over 1. And you can connect your lines. So either one of these, you get a straight line. That's why they call it linear. So again, if x equals to 1, the first power, I'm sorry, not 1, the first power, it's a linear equation, you get a straight line. If x is to the second power, or squared, that's a quadratic function. And that's the one where you're going to get a parabola or a u. And hopefully you remember that the minus 2 there means you go down 2 for your vertex. And when you graph it, it's going to come looking like a parabola, like a U. It's not straight, it's parabola. And if it was negative x squared up there, you would get one going down like that. But either way, a quadratic function where it's x squared, you're going to get a U or a parabola for your graph. The absolute value is where you're going to get the V. And if you remember this, it's supposed to be negative here, so that's a positive 2 and a positive 1. So to find your vertex is you go right 2, this one means right 2, and this one means up 1. So if you go right 2 and up 1, there's your vertex. And because there's no negative in front of this absolute value sign, you go up 1 over 1, up 1 over 1, and you get your perfect V. And there's your absolute value. So again, the difference is a U or a parabola versus a V for absolute value. Okay. The fourth one, which we may have skipped, is called exponential, and there's exponential growth and exponential decay. Growth means it grows really fast. Decay means it goes down or decays really fast, like your teeth, where if you get decay, it goes down. So the A is where it's going to cross the the y-axis. So we're not going to worry about that. For my examples, I have a equals to 1. But the b, where the base to the exponent, that's the important one. That'll tell you whether it's a growth or a decay. If it's a number greater than 1, it's going to be exponential growth. So as x gets bigger this way, y will get much bigger this way. So it'll look like this, where it goes up like that. Okay, so once it crosses that, because there's invisible 1 for the A, it crosses at 1, and as x gets bigger, y just goes up really high. So this would be your exponential growth. This one, if it has a b that's a fraction, so like 1/2, that means as x gets bigger going this way, y gets smaller. So actually it'll go this way. And it gets closer and closer to the x-axis, but it never touches. So both of them get closer and closer, but it never goes this way. So this is your growth, and this one is your decay. Okay, just so if you see it, you can tell and you can recognize. Again, if b is a bigger number than 1, it grows faster. It's exponential growth. If b is a fraction, it becomes a decay and it gets smaller. Okay, the other one we may have skipped was a square root, and that's going to look like half of a parabola, but it'll look like this, where if you notice I use the same numbers here, here, and here, where I use like negative 2 in the inside and plus 1 afterwards. That's very similar in that this here means you're going to go right 1, and this one, right 2, and this one means you're going to go up 1. So when you go right 2 and up 1, that's your starting point. That's kind of like, if you think about it, your vertex for your parabola, but the only thing with square roots is it'll go like this. It's a sidewards parabola. Okay, so you can see the difference between those 5 so far. The last one is the rational function. And you can see an example y equals a over x minus b plus c. And again, I use the minus 2 here, and I use a plus 1 here. But there's a difference. We're not going to find a vertex. Those are actually where the lines you're going to draw that are called asymptotes. And I'll explain that when I go to more detail next. But that's where they go. So in this case, x is equal to 2. So you're going to draw a line x equal, a dashed line like this, x equals 2. And then y is equal to 1. So this is, again, like saying right, 2, up, 1. But now what you're doing is actually just drawing two dashed lines, which are called your asymptotes. And again, I'll explain it later. That's where the graph will never hit. Okay, and then you would draw an xy table, and your graph would look something like this, where it's almost kind of, if you think about it, like an exponential growth, where it gets closer and closer to an axis but never touches. So this graph here gets closer and closer to this asymptote here, and closer and closer to this one, but it never touches. And this one goes closer and closer to this asymptote, and this one goes closer and closer, but it never touches. Okay, so you can see the 6 different graphs with the 6 different types of functions, and I'll explain the rational ones more in detail now. So here's section 12.1. Here's again is the equation. Y equals a over x minus b plus c. So your vertical asymptote again is lines that the graph will never cross. So for your vertical asymptote, it's x equals to b, whatever this b is. And that'll tell you where you go right or left for your asymptote. And then the plus c at the end, that'll give you your horizontal, or this your up and down asymptote. And that's y equals to c, whatever this is, and it goes with the sign. So if it's a negative, you would go down. If it's positive, you go up. Okay? So in this case, y equals 1 over x. That's saying that your x-axis, because b is equal to 0, and c is equal to 0. So it's like saying x equals 0. So this is your horizontal asymptote, and the y-axis, in a way, is like your vertical asymptote. I'm sorry, I don't remember what I said. This is your horizontal, that's your vertical. And your graph would look like this, where it gets closer and closer to the asymptote, but never touches. Okay, so if it has y equals 1 over x, pretty simple. If you have y equals 1 over x minus 2, that means your vertical asymptote is going to move. And because it's minus and it's a positive 2, it's saying you're going to go right 2. So in this case, you're going to go right 2 units, and that's going to be your vertical asymptote. And it's a line. So x is equal to 2, that's your vertical asymptote. Your y asymptote, there's no c over here, is plus 0, like saying plus 0. So it's y is equal to 0. So it's like saying this x-axis is your horizontal asymptote. And it would look like this. And I'll show you how to make a table to graph better coordinates as you do it. I'm just trying to show you how to get the asymptotes. Okay, on this one, if you have y equals x, so same thing. This is these become your asymptotes, your axes, and it would look something like this. Okay. But now if you have y equals 1 over x and you put the plus 1 after it, that's like saying now your horizontal will move up 1. So there's nothing under here like the minus 2. So that one is saying your x asymptote doesn't move, so this becomes your x asymptote, your y-axis. And then the plus 1 means you go up 1 over here, and there becomes your horizontal asymptote. And so then it would look something like this as you graph it. And again, on your graph, if you don't want to dash your lines like that, you could, if you want to train track it so you know that that's your asymptote, you could train track it like that. Okay, so like even over here, if you wanted to train track these, you know that that's your asymptote. It'll never, the graphs, the 2 lines will never touch. Okay, so now here's a couple more examples. And I used the same example that I had in the other equation with the -2. So I took the -2 from here, the +1 from here, and I put it together into here. So now what this is saying is you're going to go right 2 for your vertical, and you're going to go up 1 for your horizontal. So if it said to identify your asymptotes, this one would be x equals 2 and y is equal to 1. Okay. X equals 2 looks like this. Again, it's a vertical line. And y equals 1 looks like this. And you can see I have the two asymptotes. Now to graph it, x cannot equal to 2 because that would make your denominator 0. So what you want to do, you can use that here and put that in the middle. So x equals 2, but you don't use that. You don't want to use that because it'll never touch 2. So, but now you can go 3, 4, 5, 1, 0, -1. So you can use that as your middle point, but you don't figure it out. If you put a 3 in there and you get 1 over 3 minus 2, which is 1, plus 1, you get a 2. So you get 3 comma 2, 1, 1, 2, 3, 1, 2. It'll look something like this. If you put a 4 in there, it'd be 1 over 4 minus 2, which is 1/2. So you get 1.5. So now it becomes, you can see it's going to go like closer and closer and closer to the asymptote. And again, because my lines aren't perfect, it's looking like an L, but it really shouldn't. It should actually look like a curved line, kind of like this. Okay. And then when you do the 1 and you put a 1 over here, you get 1 over 1 minus 2, which is a -1, and you get a 0. And then if you were to keep putting numbers in, it would just keep going down there. Okay, and that's how you would do it. So you can fill in the numbers here. If you put there, that would equal to, if you put a 0 here, is that 1/2? And you can just keep going that way and figure it out. The main one I want you to do is find this one, the one that's 1 next to it on each side of your vertical asymptote. After that, you can kind of guess it. That's not that important. Okay? So here's another one here. So my vertical asymptote, because it's a +3, that's like saying minus -3. So it's x equals -3 is my vertical asymptote. And then y equals +2 is my horizontal. So -3 would go here. +2 would go here. And notice I'm putting arrows for the asymptote because they are a line. Okay, they extend out. And x equals -3, so I'm going to put the -3 here but not use it. -2 and -4, I'm going to do that. If I put a -4 into this equation, I'll get 4 over -1, which is -4. I'm sorry, yeah, -4 plus 2, which is -2. And if I put a -2 in here, I'll get 4 over +1, which is 4 plus 2, which is a 6. So over here would be -2, comma 6, which is up here somewhere. And then this one was -4, comma -2. So somewhere here. So it would just start going this way, and then it would kind of go this way, and it would kind of go that way and that way. If you did -1 and -3, actually you can't do -3, sorry, -5. If you did negative 5 in there, it'd be 4 over negative 2, which is negative 2 plus 2, which is 0. And if you put a negative 1 in here, you would get 4 over 2, which is 2, you get 4. So negative 1 comma 4 would be about here. So you can see that it's going down. And then negative 5, 1, 2, 3, 4, 5, comma 0. It would have crossed there. Okay. Sorry, I hope I wasn't blocking the, the shot. But that's kind of what it would look like. So you can see how that graph would be. And notice I had a different number. It was 4 up here, so that's why it's a little farther away from the intersection of the asymptotes. Okay, last thing is just identify and recognize the different types of function. Which one is linear, quadratic, absolute value, exponential, square root, rational, and go Steelers. But which one do you think is linear? So go ahead and pause this here and try and see if you can figure out which ones are which. Okay? Okay, hopefully you paused it and tried it. If you know this one, 5 to the x power is going to be exponential. So I'm going to put a D here. Y equals 5x is linear. Y equals x over 5 is still linear. Because it's like saying 1/5 x. Y equals 1/5 x. 5 over x is your rational. 5x squared is your quadratic. And this is obviously the square root. And this is obviously your absolute value. But if it's said to describe it, this would just say your base is 5 and it's exponential growth since this is 5. So you'd say exponential growth. This would be a linear equation with your slope 5 and y-intercept is 0 or the origin. This one is slope, a linear equation, slope 1/5 because there's invisible 1. And your y-intercept is still 0 or the origin. This one is saying that it's a rational expression, or rational equation, sorry. The x and y axes are your vertical and horizontal asymptotes. This is a quadratic function where your vertex is at 0, 0, and it goes up pretty steep at rate of 5, so it's just a thinner parabola. This one is a square root where your vertex is 5, 0, and then it has a perfect V. It would go to the right on the axis, and then it will have the half of a parabola. That's the starting point of your graph, sorry. And the last one is your absolute value where your vertex would be 5, 0, and you have the perfect V there. Got those mixed up. Okay, hope again that you have a thankful heart, everything's going good, and I hope this helps. Have a great day.